All right, so to start with, we're going to talk and pick up this one problem from the old homework. This is from 12.2. Just so you know, if you're just starting this video, this is actually about 12.3. The new thing for today is going to be about the 6 functions of trig. There's actually sine, cosine, tangent, and 3 more of them. So they're super easy, though, because they're just reciprocals, and I'll be able to teach you that in a bit. This is something we skipped the other day because I felt like I just didn't have time. Let me show you how easy it is, though. Where's that point, negative 7, 24? Would you agree it's negative 7's over this way a bit, and then up 24, which is up this way a whole bunch, so like, let's say it's like there? Would you agree by giving you that dot, I'm kind of giving you that line, which kind of gives you this angle? Okay, now, if you're going to do trig on this, you got to know some stuff like either the angles or the sides, and you can get away with just knowing the sides. Here's the sides. Didn't they already tell you 2 sides? Sure they did. What did they tell you? Negative 7 down here and 24 here. This side then is the square root of what squared and what squared? 24 squared and negative 7 squared. I happen to save you a bunch of time here, and it ends up being the square root of something which comes out to 25. Comes out really nice. That makes 7, 24, and 25 what's called a Pythagorean triple. Have you ever heard that term before? Because, 3, 4, 5 works out perfect, right? Why does the 3, 4, 5 triangle work out so perfect? Because 3 squared plus 4 squared equals 5 squared. And there's only a few combos that are like that. Other than cheating and just multiplying that by 2 and calling it the 6, 8, 10 triangle. I mean, of course, that'll work too. But do you know any other Pythagorean triples? Like what? All right, there's one more you should know, and the reason I think this is worth taking a second is it's on the ACT test. The ACT test says Pythagorean triples, and one of the 200 topics that you should know. Okay? As in, it would be a big advantage if you knew that 5 and 12, and you didn't have to take the time to go square root of 144 plus 25. If you just knew it, it's the 512. Anybody want to guess? 13, because that is the square root of 169. 5, 12, 13 is another Pythagorean triple. And the one you just learned a second ago was the 7, 24, 25. Now, to be honest, I think I've only seen that one once before. But the 5, 12, 13, I've seen a lot. So that's one I would memorize. That 3, 4, 5, of course, is the classic right triangle. But 5, 12, 13 is another biggie. Because there's only certain numbers where a squared plus b squared equals c squared works out to perfect round numbers. All right, so that was all just to say that that third side is 25. So why do I care? Because now I can find the sine and the cosine of that angle. Which angle? That's the only important angle. It's called the central angle. Would you please, right now, figure out sine of theta and cosine of theta? I know it's pretty easy, but this is part of your assignment for tonight. The one that I'm doing with you right here, number 65. And another one to be named in a moment. I'll pause for a moment while you try this one. Okay, and how many of you are already done? Okay, so I'll tell you that next I'm going to have you do number 68 in class. So everybody go and do number 68 next. This is going to happen in class, and then one more of these is going to be assigned as our assignment for part of tonight. So we will have done 3 out of the 4 at least. Do number 68 next. I'm going to pause while you try to conquer those 2. All right, just to clarify what the directions are, if you're doing it right on number 65, you would have gotten opposite over hypotenuse, which would be negative 7 over 25. And for cosine, oh, wait a minute, I just did that wrong. Sine would be opposite over hypotenuse. Sorry. Sine would be this one, opposite over hypotenuse, 24 over 25. And the other one would be negative 7 over 25. All right, so moving on to the next one, what I'm asking now is that you set up your little dot and your triangle in the right spot for that one and solve. All right? Pausing. Okay, let's see how you did. First of all, negative 2, negative 11. Basically, it's down there. And that starts with this line, and therefore a triangle that goes -2 and -11, and the third side, square root of 125. Do I remember that right? Okay, good. So then, sine, cosine, and tangent of the only important angle, the one by the center, the central angle, sine of that would be -11 over root 125, and cosine of that would be -2 over root 125. Raise your hand if you had those right. Okay, good. Now again, in some schools they would make you rationalize that denominator, multiply both the top and the bottom by root 125. But since the AP tests don't require that, we don't make you do that. Yes?
On the test, what do we have to simplify square root of 125?
Good question. Root 125 can break into root 25 and root 3. And so that would be, I believe, 5 root 3. Is that what you're thinking? 5 root 5? Oh, sorry. It's 25 times 5. You're right. Okay, so yeah, it would be 5 root 5. And yes, you should, but that's a small enough thing that I don't think I would have marked it wrong for just one thing like that. Now, let me clarify. You are supposed to reduce these all the way, but when it's something small like that, then you're going to, it's going to always be a judgment call on my part, because the rule is reduce it all the way. Okay, so last, your assignment for tonight is to do number 67, because it actually is my birth year, 1967, and I rarely see a number 67 on the assignment. And that also, for somebody smart, could help them figure out in the year 2017 what's going to happen. 50, that's right, the big 50. I'm turning 50 this year. Scary. But one of those little secrets. Oh, I've got to pause this because only people in class get to get this. Okay, so do number 67, but warning, and this is actually okay. One of the 2 keys that we have posted is an incorrect answer, but this does bring up the point that there are 2 keys posted. There is now oftentimes 2 keys, because we have a person who is making all new keys. And so if you want to look at the, if you get a different answer and you're like, I know I'm right, because they did I think it's the hypotenuse is wrong on the key for one of the keys. There are 2 keys posted. So you can look through, you'll see there's 2 options for keys. You can always double check the other key. All right, so do you have to do any of these? Yes, we just did 2 in class, 65 and 68. And then you're assigned number 67 also. The only one we're leaving out is the death number 66. All right. No, it's not really the death number. Route 66 is actually a pretty cool road, but I'm canceling it anyways. Pausing while I move to the next assignment. All right, here we go. That one is the unit circle. And do you remember me saying all students take calc would be a pretty handy thing on every single unit circle you draw from now on? Even if it's not a unit circle, even if it's just a circle, put ASTC on there. A reminder what it means. All of them are positive here. Sine is the only one positive here. Now I want you to think for a second. Remember that sine is y? So then look at these and tell me how you can know for sure that sine is the only thing that's positive. All the y's are positive. Does that make sense? See? Positive, positive, positive. Oh, just the y's. Positive. Then, if sine's the only one that's positive, that means this one's negative. Okay, take your stuff, go in the hall. Yep. You don't need to show the kid next to you what you're doing. All right, that one is cosine. Cosine is negative. Well, I said that sine would be positive and that nothing else would be, so that proves that these guys, which are all the cosines, they're all negative. And then if you take tangent, it's going to be this one divided by this one, and you get how there's always a negative in it, and therefore tangent is always negative. Okay. Now over here, we have tangent being positive. It's because you're always dividing 2 negative numbers. Do you remember tangent's y over x? Okay. So I'm just trying to show you on the unit circle, we can remind you about how all students take calc is reminding you things like cosine is the only one positive, because look, the x's are the only things that are positive. All right, so let's just do a quick review on that. Sine is which letter? Y. Cosine is which letter? And tangent is y over x. Okay, good. And for review of the last couple days, the very first thing I taught you was S equals theta r. I like to call it SOAR. Looks like this. And that is like this. if this is 8 and this is 60, figure out for me how long this side is. I like to call this the SARC because it's a dumb letter for arc. So it'll help you remember that that is the arc length formula. And there's also a formula that would tell you this. That's a wedge of a circle. It's not the whole circle, right? Would you please find the area of the sector of the circle? There's two formulas. I already put one on the board. Hopefully you know the other one. Try to answer those two questions about this circle. I'll pause while you try those. Okay, quick catch up. If you put 60 times 8, I hope you would have caught yourself in doing 6 times 8 is 48 and said this is 480. Wait, that can't be 480. If this side was 8, how could that be? So what's wrong with what I'm doing? Has to be radians. Can't be 60 degrees. Has to be what? What kind of radians? How many radians? Pi over 3. So the answer was 8 pi over 3. Raise your hand if you guys had that one right. Okay, good. The next one, the area of the sector, would be 60 out of 360. That's what fraction it is of pi r squared, because pi r squared, of course, would give us our circle. But I know r. R is 8. There we go. Now that is not simplified. You'll be able to leave answers like this on the test, but you have to simplify them to get credit. So how could I simplify this? Watch. 0 is cancels like that. So it's now 6 over 36. And that can cancel further, can it? 6 goes in here 1 and 6. Now it's pi times 64 over 6. And are both these even numbers? Yes, they are. And therefore I can go a little further. 32. So I have 32 pi over half of 6 is 3. That would be reduced all the way. How many of you either had that or something that wasn't quite as simplified? Okay, good. All right. So that's a review of the first day. Then we got into where in the world is 11 pi over 2? Well, where is 1 pi over 2? Everybody start by putting a 1 pi over 2 mark on here. Where would 1 pi over 2 be? Right now. Right now. 1 pi over 2. Did you put a mark right here? That's where pi over 2 is. Good. Where would 11 pi over 2 be? Well, 1 pi over 2, 2 pi over 2s, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's down here is where 11 pi over 2 would be. Now what's special about these kind of spots is you can't draw a triangle for that. But you can use those little rules like we just learned, since this is at 0, -1, to say like, what's sine of 11 pi over 2? What is sine of 11 pi over 2? Well, sine's the y, right? So it's -1. What is cosine of 11 pi over 2? 0. And what is tangent of 11 pi over 2? It's -1 over 0, undefined. Okay, good. So we're going to do another one like that. What is the sine of 5 pi? Figure out where the heck where 5 pi is first. And then find the sine of 5 pi. Well, first, you don't want to figure out 5 pi. Figure out 1 pi, and then count it up from there. Did you guys think it was right here? Raise your hand if you thought it was right there. You are right. Good. Okay. So then, what is sine of that spot? Well, you'd need to know what point it's at. What point is there? -1, 0. And therefore, the sine is the y, and therefore the answer was what? 0. Okay, good. Now, what if we said sine of some angle I don't know is -1/2? First of all, make your circle with the ASTC thing on it. And then figure out where this triangle is. Hint, you can draw a triangle for this one. In fact, you can draw 2 triangles. Very good. all students take calc. Here's the way my brain thinks. Sine is positive here and here. So since sine is supposed to be negative, it can't be here and it can't be there. Raise your hand if you knew that. Okay, good. Then, in this problem, draw me the two triangles, and there are two angles, and I want them in radians. So give me two angles in radians that are the answer to what is theta. I'm going to pause. We'll give that one a try. Okay, because I had a person who was gone the other day, I'm going to explain this really thoroughly. And listen, do you get, since I know it has to be here because sine is positive, or sorry, sine is negative, and therefore I must be in this quadrant, then I can set up my little triangle where sine is opposite over hypotenuse, and that must be root 3. Do you get I'm in the 1, 2, root 3 triangles? All that making sense so far. Are you with me so far? Okay. Then this angle is across from the one. I know that one. It's 30. Why can't you just say the answer is 30? Because you'd be back over here, and that's where we can't be because sine is negative. So it can't just be 30. But it's kind of like 30. It's all the way around here plus the 30, which makes 180 plus 30, which would be 210 degrees. Raise your hand if you had that one right. Okay, but I did say in radians, so how many sets of 30 is that? It's like 7 times 30, which means 7 times, and since 30 is pi over 6, it's 7 pi over 6. That's my favorite way of doing that. If you want to just count it up and figure out, okay, that's pi over 6, and then go, okay, well, this is 6 pi over 6 plus 1 more. That's a great way to do it, too. Well, 7 pi over 6 is one of the answers. Do you get how I got that? Okay, good. Then there's another answer, because if you just simply type this into your calculator, you don't have to right now, but if you typed in sine of 7 pi over 6, it would give you negative a half. But there's another thing you could type in your calculator. It would also give you negative a half, and it's located over here. You do not have to redraw everything. All you need to know is that that's a 30, because it'll still have the same central angle. Then you can use logic to go, well, this must be 330. Like 360 minus the 30, 330. And if I did that, I'd be thinking that's a whole bunch of 30s. How many? 11 30s, which would be 11 pi over 6. There's more than one way to get that, but the two answers are 7 pi over 6 and 11 pi over 6. Yes? Oh, no. What happened here? Sine is opposite of hypotenuse. Oh, yes, this is negative, but you're right. In this case, I didn't actually need that to be negative because I was never asked, but if they had asked me, like, what's cosine, then without that negative, I'd have been toast. So you're right. Thanks for pointing it out. It doesn't change our answers, but this is supposed to be negative. It happens so much. It is the most common circle trig mistake. Now, in this case, it didn't burn us, though. Had they asked us cosine of theta must equal what, then we'd have gone through and said, oh, adjacent over hypotenuse, and it would have mattered a lot. All right. Last kind, the new stuff. The new stuff for today. Get a nice blank Notability doc. It doesn't have to be a whole doc. It's just a page anyway. You need a lot of room for this one, is what I'm trying to say. Don't try to squeeze this between things. On the left side, make a little circle. And on the right, put sine of 30, cosine of 30, and tangent of 30. Has anybody memorized any of those? Yes? Is 1/2. Good enough. Stop. That's all we need for now. That's the one I would expected you to memorize, because I told you a long time ago, memorize sine of 30. So, do you know where we are? If we're saying sine of 30 is 1/2, there's one logical place to for sure draw the triangle, because we aren't doing what angles make it equal 1/2. I said it was 30. There's only one place that's 30. It's right there. And that's 30. Would you please draw the triangle that corresponds with that? Make the little triangle, and then I'm going to show you. We know sine, cosine, and tangent. Those are easy. But now you're going to learn the new ones. I'm going to pause while you get caught up to here. Do you know any of the other three? There's sine, cosine, tangent. You know one of the other three?
Yeah.
What is it? Say it.
Sec.
SEC, yes, SEC, sec is a function, but it actually is short for something. Just like cos isn't a function, but cosine is, right? What's sec stand for? Secant, good. And it is across from this one. But just to be clear here, cosine of 30 isn't secant of 30. They are not the same thing. If they were the same thing, we wouldn't need them. They're what are called reciprocal functions. So let me just finish this. Cosine of 30, since this is 1, 2, and root 3, cosine of 30 is root 3 over 2. You should have had that. And tangent of 30 is 1 over root 3. You with me so far there? Then squeeze next to cosine, squeeze in secant of 30. I'm going to slide these all over a little bit so that I can make room. I'm going to try to slide everything over a little bit then. There we go. Because secant of 30 is the flippin' sister of cosine. Do you know that Minnetonka has a sister school? And in Beijing, there is a sister school. And it's a lot like our school here. It's just that it's in China, as in they're in a suburban area. They have, similar age students, and it's just that everything's in Chinese, of course, except not really. They learn English way better than they learn Chinese. A very small percentage of our people that graduate from here will know how to speak Chinese, but a huge percentage of the people from China will all know how to speak English. So they'll have a little advantage on us in that respect. But our sister school in China is like us, except different, right? Well, these are sister functions. This secant of 30 is like cosine, but it's different. And it's really simple. If I call them the flippin' sisters, it's because they're reciprocals. They just flip. So this root 3 over 2 becomes 2 over root 3. You just flip them. Now, let's get the rest of them. Who knows another one? Secant was one that somebody knew. You knew one? Cotangent, exactly. And that, surprisingly enough, goes across from tangent. But it is the only one where the co-function is the flippin' sister of the original. But anyway, you don't have to memorize all that, but you do need to know that cotangent of 30 would be the flip of tangent. So tangent of 30 is 1 over root 3, so this is root 3 over 1. And the last one. Yes, sir. Cosecant. There's pilot and co-pilot, right? There's tangent and cotangent. There's sine and cosine. Then there must be secant. There must be cosecant. And the reason, or the abbreviation is a little tricky, though. CSC. Cosecant is the flippin' sister of sine. Sine and cosecant. Cosecant, therefore, must be 2 over 1. And it's just a flip. Now, I want to give you a couple ways you can remember which ones go with which one. Would you agree that sine is opposite over hypotenuse? Cosine is ka, adjacent over hypotenuse. And toa, tangent, opposite over adjacent. Now, I could give you a new saying. If this one's opposite over hypotenuse, then do you get it's flipped and it's going to be ho? And this one's going to be ha. And this one's going to be ao. So you could say cho, sha, cow. I know. Sokotoa and Chosha cow. Now, I don't think anybody in the world teaches it this way, though, because it's an original of mine that's completely useless. Because cho, sha, cow has got 2 C's in it. It'd be really confusing which one was which. Okay? But it is true. If I gave you this triangle and said, find the secant, for instance, you could go, okay, sha, secant is hypotenuse over adjacent. So here it is, hypotenuse over adjacent. So the secant of 30 would be hypotenuse over adjacent. But I don't think that's the best way to go. Because you'd have to memorize Cho Shakao, and then you're going to be like, is that cosine or is that cotangent? Okay, so that's not the best way to go. The best way to go, Gandhi would be proud of this one, is nonviolent protest. So when I give you cotangent of 30, I suggest you say politely, Mr. Server, I refuse to do cotangent of 30. But I will do tangent of 30. Because I know how to do that. And then what? Flip it. So you don't do cotangent of 30. You do tangent of 30, which I can do. That's easy. TOA, opposite over adjacent, 1 over root 3. But it's really critical that you remember that the original question wasn't tangent. It was what? Cotangent. So then you got to remember to flip it. Flip it good. I'll be playing a Devo song later. Okay. Anyway, let's see if you can get a new one. That's the one we haven't done yet. Secant of pi over 4. Holy crap, that involves radians, which you didn't know until last week, and a new function that you didn't learn until today. Can you pull off secant of pi over 4? Remember, Gandhi would not agree to just do this. He would say, I'm sorry, I will not do that for you. He would peacefully protest and do something else. I know, Gandhi's spinning in his grave somewhere, but it makes the class a little more interesting. I'm going to pause for a second while you give this one a try, but don't do secant. Do something else that you know how to do. Unless you're going to memorize Cho Shakao. So hopefully you said, no, I will not do secant, but I will do cosine. I hope you knew that that was the flip of pi over 4. And then I just got to remember that what I get for cosine is not actually my answer. Okay, so where is pi over 4? It's that guy, it's 45, and cosine is adjacent over hypotenuse. No, yeah, it's adjacent over hypotenuse, that one over that one. So it's 1 over root 2. The sad, wrong answer would be that, because that's cosine. We want secant, so we got to flip that and say root 2 is your answer. Raise your hand if you had that one right. Good sign. Okay, good. So this is the new stuff for today. You have to be able to handle it when they do bigger angles too. So let's just do one more. Let's do cotangent of 7 pi over 6. So you got to do two things now. You got to figure out where the heck cotangent or pi over 7 pi over 6 is, and then you got to figure out not cotangent but the other one. All right, try this one. I'll pause for a second. All right, let's see what you should have had. Here's where 7 pi over 6 is, and that makes this pi over 6, but I like to call it 30 because it's in a triangle that I call the 30, 60, 90 triangle. Nobody memorizes it as the pi over 6, pi over 3, pi over 2 triangle. So I'm fine with you calling it 30, 60, 90. A little quieter would be good. Then over here we have a 1, except most common mistake in circle trig, negative 1. And here we have a 2, here we have a root 3, also negative. And then, am I really going to do cotangent? No, I would resist. And I would say, I am going to do tangent of 7 pi over 6. And then I'm going to get my answer and flip it. Okay, so I just got to remember to flip it and not just stop at tangent. Tangent is opposite over adjacent, which is negative 1 over negative root 3. Yes, the negatives cancel. But then I'm going to flip it. Final answer, flip it. Flip it good. Raise your hand if you had that one right. Good. Okay. You get the extra 3 functions then because they're just flips of their sister function. But here's the hardest part. What does sine go with? What's over there? Cosecant. What does cosine go with? Secant. And what does tangent go with? Cotangent. As long as your memory holds up, that part of the test should be easy. Okay. So now, let's look at your homework together. There is several skips in there because I want to keep it reasonable. You keep doing it. I keep it reasonable. It's a reasonable compromise. So let's get to assignment A1 right here. And these first few are all very reasonable. There's nothing tricky. In fact, there's nothing quadrantal. Do you even know what I'm talking about? If you know that those are the spots that are like here, how on earth could you draw a triangle for 0 degrees? You couldn't. And so therefore you have to use the point method. There's nothing like that on this front screen, but there is on the next page. Let's see if anybody can find it. Where is the one that would be on a quadrantal? Number 19 is on a quadrantal. Very good. 18 would also be on a quadrantal because 7 pi's, well, first 1 pi is here, and then you got to do that 7 times. You'd end up on a quadrantal. 11 and 12. So I think we got enough examples in that first row. Cross out this row. Yeah, that's a quadrantal, and that's a quadrantal. You got to make sure you know how to do that kind. Remember, on that kind, sines y, cosines x. What's tangent? Y over x. Okay, good. All right. So you can cross off that whole bottom row there. Next page, we need to cross off number 30. Just try to keep the size of this down. And we need to add something to number 29 because the assumption is they want you to figure out the angle, which won't be possible without a calculator. There's no calcs on the test. So what am I going to do? I'm going to change this to find cosine, no, sorry, sine. I want to keep it the same as the other classes. Find sine of theta. Okay, so you're going to first figure out, okay, I'm not going to do cotangent. I'm going to do what? Tangent of this angle, which will be a flip. So it will be 1 over square root of 5. Okay, and then I can make a picture for that. And where is tangent positive? Oh, wait, it says it's in quadrant 3. So I can cross off all the other quadrants. And so anyway, there's a lot of little tricks to this, but the main one being that you can't just do cotangent because you're not good at them yet. But you could do tangent and flip it. And now you'll get some sides on a triangle. When it's all done, you'll be able to find sine of that angle for me. All right, so there's become like lots of little steps. One little step at a time, it's not that bad. Okay, cross off the Challenger questions. If you have the time, feel free. And here, cross off number 66. We're going to do number 67. Again, rare opportunity to choose my birth year as the problem number. Yay. And then we're going to cross off 77. And cross off 79. And, of course, the Challenger. This, I think, is kind of interesting, but I'm not assigning it. But if you are interested in knowing what calculus kind of looks like, this is what calculus kind of looks like. So I know I've got a few kids in here who are going to be, well, a lot of kids are going to be in calculus, but some might actually be interested in what does calculus trig look like. Again, not assigned, just in case you want to know. All right, so let's get back to something that was assigned. Let's look at this page, and let's look at number 4. Everybody try number 4 in class. We'll just use it as a little test of the emergency broadcast system. Or in this case, the emergency trig checking system. All right, I kind of like this method. Here's 1 pi over 3. So then 4 pi over 3 must be 3 pi over 3 from that, which is like 180 from that. So boom, it's down there. There. That's where it is. And then I can draw a triangle. And then I can go, I don't really want to do cotangent. I want to do tangent of the same angle. Notice I don't flip the angle. That's a common mistake. People think that they understand. You only flip the answer. You don't flip the angle. There's no such thing as flipping that to 3 pi over 4. That would be wrong. Okay, so anyway, tangent of 4 pi over 3. TOA, oh wait a minute, this is pi over 3, so 60, that's a 60, which makes this a 30, which makes this a 1, 2, root 3, negative, negative. From there, I think you should be able to do it yourself. You want to do tangent. Remember, you don't have to flip the angles over. You just flip the answer over. Tangent of this would be one thing. Cotangent should be something else. It's the right side that flips, not the angle. Okay, so tangent would have been negative root 3 over negative 1. Oops. Yeah. And then cotangent is not that. It's the flip of that. 1 over root 3 when the negatives canceled. Raise your hand if you had that one right. Okay, cool. I think you understand the new stuff for today.